Hey, good afternoon, everybody. Welcome back to Unqork's Twitch channel with this show, because we're going to try to make this more than just one show going forward. So stay tuned for that. But today's show, or this show, is as always the Uncoder. So I know I say we're always going to do fun stuff, and I really think we have done fun stuff. But today I think it's going to be really, really fun because we're going to start off with nothing really no code related, but will be a lot of fun. And we're going to dive into building a video game, right? Now, this is something we've been trying to get in for a while. You'll see the theme of it is very wintry, and I know we're getting into we're in the thick of spring and summer's right around the corner. So the fact that I have an iceberg in the background and everything maybe isn't very timely in terms of the weather, but we just had so much other awesome content to show you that we had to push this out. So before I dive in, I want to set a little bit of context for everything that you're about to see, particularly the beginning part of it. So this photo is from Antarctica, and I took it while I was down there when the pandemic struck, right? I was on a boat in Antarctica when the pandemic hit the world. Very interesting, and there were certainly concerns while we're down there. We're going to be one of those boats that gets stranded, at a port and, live on the boat for the next month. But while we did get back, we had a delay. We got back a week later than we were supposed to get back. And we spent that whole week sailing up the Argentinian coast from Antarctica all the way up Argentina until eventually Montevideo allowed us to get into their port. So, entonces, muchas gracias otra vez a los uruguayos. Thank you again, Uruguay, for letting us in and back into reality. But in that additional week, that we were on the boat ran out of stuff to do with us. So they basically turned it over to the folks on the boat, and they said, "All right, you entertain yourselves now," right? So a bunch of people started to just, give presentations on subjects that they were interested in and things like that. So I decided to make a mock presentation about a subject which maybe is real and maybe isn't, called snowology, all right? The study of snow. So basically I'd done a presentation on the boat about, the level of snowology and being a snowologist that I have, right? Came back to America after that, presented it to my fellow Uncorkers at a time where I think people just needed a good laugh, and I thought it was pretty funny. And then a year later, so last year, we did another one. I did another snowology presentation, and this one was really focused on Unqork and snow and the combination of the two. So, and that led to the building of a video game that we're going to show you. So the main focus of this, and it's going to probably be two parts. We're going to cover some of it today, and we'll cover some of it next week, is really going to be how you can build video games with artificial intelligence and dynamic interactions on the screen, all using Unqork. Again, not a financial services insurance platform. I think we've really tried to focus on, the breadth of things that you can build with Unqork. So this, I think, is another great example of that. But before I do that, I would love to share with you a little bit about snowology. So without further ado, let's jump into that. And I think I just need my screen to go up. Am I sharing? Live comments. All right, there it is. Cool. So we're up. All right, so here it is, snowology. Everything you need to know about snow code, brought to you by Broation Expeditions. Brocean-wide, Broation. That's because I won't even get into the Broatia jokes. Brocean-wide Expeditions. Cool. So we're going to start off today with a snow review of what we're going to cover. We'll start with an introduction to me. Then we're going to do an introduction to snow code. Then we're going to talk about the differences between snow below code and snow code. And then we're going to get into that demo, and then we're going to dig into that demo after the fact. So who am I? I'm Sir Nicky Gamble the 40th. PhD, MD, DODDS, RN, JD, Esquire, CSM, CPM, CFA, Dark Lord of the Sith. And more recently, CPA and CRV. Now, that last one's just a joke, though. That's a car. Cool. Some background about me. I was born and raised in the Indian jungle. You'll see there the photo on the right, one of my favorite photos. That's me and my parents. But an interesting fact there is my father on the left, that's actually my stepfather. My biological father abandoned me as a child to pursue a career acting in commercials. It's a very conflicting set of emotions, I got to tell you. I love Coca-Cola, but I hate him. And just to note, this joke was not sponsored by Coca-Cola. I studied abroad in South Beach, Miami. Me and my boy right over there, crushing it every day. But interestingly enough, I was in Miami studying Arctic marine life. As a snoologist, of course, and ambitions of being a snoologist. So, studying Arctic marine life in Florida, you might imagine that could raise some red flags. And it sure as heck did. And it resulted in me being the primary suspect in the infamous kidnapping of Snowflake, the Miami Dolphins mascot. This led to a very comical series of events with a notable pet detective hot on my trail, but fortunately, everything got laced out. And lastly, as much as I love the snow, I live in a Berber tent in the Sahara. And I have to tell you, ever since all this work from home started, it has made things a little bit difficult. But once again, thank you to the Unqork IT team for sending that hotspot. It was a real lifesaver. But enough about me, right? You're on this Twitch to learn about snow code. So let's talk about snow code. And I think the best way to do that is to go over some of the components that are available to you when building with snow code. So the first one I want to talk about is the gauge component. All right, this is one of our display components, and it allows you to do, just as its name implies, gauge things. That could be anything from gauging a drop in air pressure, maybe, to look for an indication of oncoming snow, or even how often our creators are using the gauge component, which you can see here. Now, interestingly enough, again, this is a one-year-old presentation. We have since deprecated the gauge component based on some great data there as part of Snoology. Next up is the initializer component, initializer component, I should say. And this is one of our simple logic components. It allows you to take a number of different actions on the page. So some examples of what those actions could be, you might want to set the value of something. So I could say that the value of the year property is any year but 2020, please. We all remember 2020, right? You can trigger things, all right? So I might want to say that the no masks property triggers me. You can set the number of steps that something should take. So an example might be to set the Fitbit property to 0 steps, which is probably how many steps you got during the pandemic. You can also set the duration of something. So you might want to say that the lockdown's duration is way too long, or was way too long, thankfully. And finally, you can say whether or not something is visible. So you might want to say there that the property, the light at the end of the tunnel, yes, it is visible. And I think now we can all say for the most part, we are through that tunnel, we're out the other end, and we're all very excited about that. So, great job being diligent over the last few years. And lastly, I want to talk about the data work snow. So this is one of our complex logic components. And I would say probably a lot of everyone's favorite. I would also say that we can agree that every data work snow is unique. You might even say it's unique like a snowflake, which is why it's great that there was a feature that came out recently in the data work snow called manual layout, which allows you to use it to design snowflakes. This is really, really great, especially for kids in the classroom around the holidays, as a way to start training the next generation of snow coders. All right, so now that you know everything about snow code, why don't we talk about snowblow code versus snow code? What is the difference? It's a very popular subject. You've seen probably a ton of articles written about it, so let's dig into that. So the first major difference here is the learning curve, okay? Snowblow code has a very steep learning curve, as you still need to learn some code. And as we all know, learning to code is hard. Often, by the time you've figured it out, you've already frozen to death. Whereas with snow code, it's very easy to learn with an intuitive visual user interface, allowing you to jump right in without a care in the world. I mean, come on, who would you rather be? Second major difference, legacy. With snowblow code, you're allowed to inject code into the snow, and that immediately creates legacy snow. Injecting code into snow to build software, that's like injecting Lysol into your body to fight COVID-19. It's not a good idea. Whereas with snow code, there is no code injection, so your snow is always pure. For example, here, a year later, you'd think I would have swapped this out to the right photo. Not what I meant to show, but let's talk about it. So in this photo, you'll see one of our Snowlutions engineers, or as we like to call them, Snowlutioneers. And what she's doing here, she's using what's called the content component, and she's using it to inject code into the snow. And as we said with our friend here on the left, that's not a good idea. She is one of our best and brightest. We're very disappointed she was doing this, and we're even more disappointed that she's so happy about it. But bottom line, no content components, no code, pure snow. And lastly is the technology, right? Because it's all about the technology. With snow below code, it's built on ancient technology designed for trends of the past. It's effectively like Thomas the Tank Engine fighting his way through some pillow stuffing masquerading the snow. Whereas snow code is built on modern technology designed with mobile, IoT, and AI in mind. Basically, the train from Snowpiercer. Not a great movie, but a great train. All right. So what else? Demo. That's it. No, snow code. Now let's go into a bit of a demo here. Okay. So for this demo, we're going to show this game that we built. Okay. It's called Don't Cork the Ice. All right. I don't know if anybody, when they were a kid, they might have played a game with their siblings or parents or whomever called Don't Break the Ice, where you had a little penguin sitting on top of a sheet of ice and you had to use a hammer to knock blocks of ice down, and you don't want to knock the penguin down. Well, this is that with snow code. All right. So in order to start playing the game, first thing we're going to do is we're going to log into the game. All right. Now, I don't need to remember a password, do any of that good jazz. I just enter an Unqork email, or what's before the @unqork.com and Unqork email, and I can get a link. Now, for anyone who's not an Unqork employee watching right now, which I hope is many of you, you can't play today, but if you really, really want to, throw it in the comments. Tell us how much you want to play Don't Cork the Ice, and we can certainly talk about opening this up to the whole world, right? So let us know how badly you want to, cork the ice. So I'm going to hit send link. It's going to tell me a link is skating my way. All right, so I'm going to hop over to my email, which hopefully you can't see right now. And I'm going to grab that link, okay? So I'm going to copy that link, jump back into this tab, and I'm going to log in. All right, cool. So now I'm in to the main games page. All right, and this is going to show me a bunch of different things we have going on. You can see it's been a while since I played Don't Cork the Ice. I'm really excited to play again because these are all the games I've been playing against the computer. Again, we're going to talk about the AI probably next time though. And then I can play against some other folks. I can join a game if anyone else was in the middle of a game or started up a game and didn't have someone to play against. I can join it over here. I can watch a game. All right, I can actually just go in and if I'm bored and just looking for something to do, just go watch some people play a very riveting game of Don't Cork the Ice. Or I can just look at some previous games and see how folks did. All right, you can also jump over here to the rankings. So this is basically our leaderboard, who's doing the best. And looks like, we've got a few folks who are undefeated at the top here. And also look at that, our AI is doing pretty darn well. Right on, so there's our rankings. You can see how folks are doing. But let's play, right? That's what we really want to do. So in order to do that, I'm going to come over here. I'm going to hit this plus button. And it take me to a new game. And I have two options. One is a one-corker game. So that's me playing against the computer, which again, I'm going to save. Also, we have a two-corker game. All right. So I'm going to play a two-corker game today. And I'm going to start that up. All right, cool. So now I'm waiting for an opponent. While I'm waiting, why don't I go and why don't I look just to see how to play? All right, so I'm going to pop up the question mark over here. I'm going to look at the rules. All right, so what's going to happen is corkers are going to take turns tapping a block of ice. So I'm going to click on one of those blocks, one of these squares. All right, let's tap. When you tap a block, it's going to fall, right? Just like you would hit the hammer and don't break the ice. And then anything around it that's now unsupported is going to fall. So what do I mean by an unsupported block? An unsupported block is one where two adjacent sides are open. Right? Because effectively, consider there being a nice wall around this sheet of ice and pushing in. So if a block doesn't have pressure coming at it from both sides, if it has two sides that are open, that means there aren't something pushing from both sides. It doesn't have the support it needs. It's going to fall into the water. All right. Now that could be a really, good thing to do. Maybe hit a block and create a bunch of other blocks to fall down. Might be a strategic way to play, or might accidentally lose you the game, depending on how astute you are. And then lastly, as I kind of indicated there, the game is over when the block with the cork falls. So you're not going to hit that block, but you might hit another block, which then causes the block to fall. All right, cool. That's how we played. Now, obviously, it's a two-Qorker game. So we do have a Qorker who's going to join. And joining me to play some Don't Qork the Ice is Danya. So pop on, Danya. Say hello. Now, Danya is the machine and the magic that makes all of these Twitch episodes happen. You have not seen her face yet, but she is always behind the scenes, making sure my face shows up, our guest's face shows up. We're sharing content, making sure I don't miss any great comments from you. So a world of thanks to Danya for everything she does for this. And why don't you say a little bit more about yourself?
Hi everyone, I'm Danya. I lead social here at Unqork, and I'm nervous because I've never played this game before, but I'm super excited.
All right, awesome. Yeah, so we're gonna play here, but it's my turn first. All right, so I'm just gonna go ahead. I'm gonna click a block of ice. All right, cool. So registered it and it passed control over to Danya. Now it's your turn.
Okay. Let me see.
All right, obviously, as you can see here, I'm not going to be refreshing. I'm not doing anything like that. I'm just sitting and boom, there we go. And now the controls come back to me. So let's just go again. I'll send it right back over to you. It's going to start getting very intense very fast. All right, cool. Now I want to demonstrate something here. So I talked about those unsupported blocks, right? So if I push something, apologies if you hear anything in the background. We have some humpback whales that are mating across the street from me in the Lower East Side of New York. So apologies if it gets too loud. The beauties of the big city. Right. So now I'm going to create some chain event, right? So I'm going to do this, which means once I click this block here is not going to have a block on both sides of it to press in, right? I'm going to get rid of this. It had nothing here. It has something here. So it's only supported from these two. So I'm going to get rid of this block. And that's going to create a whole suite of blocks to fall, right? Because all of those lost their control or lost their support. Ooh. All right, now let's get really nuts here. Let's see if we can make some real crazy stuff happen. You know what? I'm so thankful for everything that you have done for this Twitch that I'm going to forfeit this game to you. You deserve it. You deserve a big win.
Thanks, Nick. I'm gonna practice. I'm gonna keep practicing, and then maybe like next time or another time, I'm gonna really figure this out. But no, this is super cool. Thank you. But I want to win the right way.
That's fair. That's fair. But you earned it either way. Thank you for popping on. Thank you for playing, and yeah, thank you for everything.
Thanks all. Bye.
All right. Cool. So let me just check. We got a lot of comments today. Thank you, everybody, for being super engaged. Keep them coming. Keep them coming. So now that we've seen the game get played, what we want to do here is we want to just talk about how it was built, right? Because it's going to use some patterns and some approaches that may not be typical in your traditional internal tooling and customer onboarding or a number of the different things that folks are using Unqork for, traditionally speaking. So I want to dig into that. And if at any point, because it's not going to be a lot of live building, it's just going to be a lot of overview of configuration that's already there. So if at any point, you want to dig further into something, please just throw it up in the comments. Let me know. And we can certainly, drill deeper into any of the concepts or any of the components and things like that were used. Okay, so let's jump over into the application, Don't Qork the app application. It's pretty light, right? There's not a ton of modules here. We're just going to walk through, kind of step by step, the things that I showed and how they were built. So the first thing is the login, right? Now I just gave in an email and then I was able to get a link to log in. So let's just talk about that for a second here. Okay, so if I go into this API module, which is going to go ahead and actually create the user and send the link to the user. So how did that work? So effectively, what we're doing is, I don't know how many folks use this pattern before, but if you use like a Google or a Gmail email address, there's this pattern where you can put a plus sign in your email to basically create a number of different unique emails that all kind of route to your same inbox. So that's what we took here. We took that approach here. And basically, whenever you type in your email to me, what I'm doing is I'm just going to add plus DQI before the @ sign. So, maybe you already have an account in the environment that this game is in. So I'm just going to create you a unique account for playing Don't Cork the Ice, and I'm going to give you the appropriate role, which is a corker. So you only have access to the game and you can't access anything else in the environment. So that's how we're going to create our user with an email address that has appended with the plus sign. Okay, then what are we doing? Then we're doing something called creating a refer string. All right, so this is a service that is available in an Unqork plugin and then given to you in Unqork out of the box, which, as the name implies here, generates an encrypted refer string for authentication. Okay, so that's where I got back, and I think I should still have a copy. You see it here, right? Here's a nice, long, unique URL that has a timeout on it. I'm sure you've seen this before, password reset emails, things like that, where if you don't hit the password reset email in enough time, that you're going to have to do it again. Very similar concept here. If you don't click this in a certain amount of time, the link is going to expire. So it's secure. You can control how long it expires. And that security is a really big aspect of this, because I think if you talk to a lot of security professionals, a lot of people are trying to go passwordless, right? It's hard to remember your passwords. Obviously, they can get stolen. And you might, if you want to remember your password, a lot of times people create really easy passwords to brute force. So there's just so many problems with passwords. And so then you started getting some of these, password managers, and now you've got some identity authenticators that just kind of avoid the whole nonsense of passwords. So as more and more technology is going passwordless, you can really think about the Unqork refer string as a way to introduce a passwordless, very secure authentication into your Unqork applications. So every time someone wants to play the game, they ask for a new link, which then they have access to that email. They know it's an email account. It's an email account that they have access to. There's most likely going to be multi-factor authentication on top of their email. So using that as a way to authenticate rather than potentially very weak passwords, even though Unqork is going to secure the passwords that you may use in it, they can still be weak and they can still be brute forced. So you might want to consider this as an authentication mechanism into Unqork. So this is me saying, this is the user ID. It's going to expire in 4 hours. And this is some additional information I want to pass in. So I think that's a really good feature for security and also simplicity for your users, right? Not making them have to worry about an additional password. And then, of course, you've seen our email integrations before using SendGrid. Another shout out to SendGrid. I think someone joked on our marketplace one that although Coca-Cola didn't sponsor our joke today, it kind of felt like SendGrid had sponsored our marketplace. But it is really a great platform. We have really great integrations with it. So I am using SendGrid to send that email. Cool. So I authenticated, and now I'm in. And let's go and let's show that homepage, right, where I had a bunch of different games up on the homepage, right, which was this one over here, the games page, right? So I'm querying back a number of different types of games, my games, games that are going on but I'm not involved in or don't have anybody involved in, games that are going on but I'm not involved in, and games that are completed. So a lot of different queries that are happening here, but they're all kind of doing the same thing, right? So we have a plugin to get the games for the users, a plugin for the ones that are waiting for someone to join, in progress, and games over. So it's a lot of the same, right? It's really a plugin and a view grid, plugin and a view grid. Now, obviously, when we had our Twitch a couple of weeks ago, we talked about some of the new grids. I would love to be able to just switch this over to a new grid, but this is using the view grid. I still love the view grid though. And then if you click on any one of them, you want to open that game. So it's a lot of similar stuff, and we don't want to have to repeat a lot of the component usage. And sometimes, and you really want to, again, use that, get that reusability from what you're doing. So for each one of these games, it's doing the same data workflow, right? For each one, it's going to rename some fields to make them easy to access. It's going to create some new fields to determine winners and losers and opponents. So this is something that is happening on all the sets of games, even though those games are being independently queried back. So I don't want to have to copy paste this multiple times. I don't want to have to put this into a different module and execute it. I really want to be able to use this kind of like asynchronously and in parallel. So one of the ways that, I thought to solving parallel processing in Unqork here is, let's consider I'm going to have 4 types of games. I'm going to have the ones that are mine, the ones that are waiting for someone to join, the ones that are going on right now, and the ones that are over. All right. So I'm basically going to create an array of, I'm going to create an object here where it has a property for each type of those arrays. right? And then that is going to allow me to effectively, if you see up here, fire all of these plugins off in sequence. I don't want to have the user games run, and then when it's done processing, go trigger the waiting one, and when it's done processing, go trigger the next one. I want that all to happen really, really fast, right? And I want to be able to populate that data as quickly as possible. So these are going to run all in parallel, and they're all going to trigger the same data workflow here, leveraging the reusability of it. And then what that's going to do is, after it's done the processing, it's going to then it's going to set the property inside of that data table I showed you earlier with the blue headers and the 4 columns. It's going to set the appropriate columns value, which means I can actually have this data workflow running multiple times at the same time, and it's still going to write data into the appropriate place. So something to consider when you're really trying to get parallel processing in. Can we call them plug offs from now on? I don't know. Submit it in platform feedback and we'll see what happens, or submit it through community and see what happens. So that's just a way to consider running, those multiple processes in parallel and then merging, basically like a map reduce, right? We're going to do all this stuff. We're going to merge it back together in the end and really get a lot of performance benefits out of it. That's really what I wanted to touch on the games page. We have the rankings page here. I don't really think there's much to dig in from a configuration perspective on the rankings. Obviously, just some calculations to determine your win percentage and then sort accordingly. And obviously, you want to weight 2 people who have the same winning percentage, but maybe one has won more games. You want to nudge up a little bit higher. So there's some logic that goes on through that. I mean, that's what happens in a lot of the major sports. You go look at the standings, and if one team has played 2 more games than another team, but won and lost one, they'll be higher up in the standings. So similar concepts going on here. But where I think a lot of the fun is, when we really want to spend a lot of time going in, is the actual game itself. Okay. So here is the module for the game, and it's broken down into the sections of what the various things that are going to happen within it. And the first thing we're going to start is we're going to talk through the schema. Now, we've shown you the schema docs dashboard before, and the schema specification, and the concept of building a dedicated module that functions as a schema. For this one, because it was a fun build, I decided to go a little bit of a different route and actually leverage using this page itself. The UI page is also the source of the data, which is why when I go back and when I look at any one of the games that are being played here, it's loaded through the URL. Right, so this is the module path that I'm accessing. This is the unique identifier for this game. And then this, again, is that module path. So I wanted to really leverage this pattern and, kind of make one module that's super powerful and kind of handle a lot of the stuff. So down here, we have our schema, right? And the schema is pretty light. What we're storing in is it a status. So that's what status in the game is. It is ongoing. Is the game over? Is it waiting for somebody to join? The turn, what turn we're on. The board, so the board is going to be that grid of boxes you saw, or blocks that you saw. The players who are playing and whose turn it is, the current player. Right, so a pretty straightforward schema design that we have here. Okay, now what happens when we want to start a new game? Pretty straightforward. We just have a radio button here and a button. Of course, we conditionally hide or show that whether or not the game is going. And then we're going to start the game, which is going to kick off init edit. All right, so let's jump down to actually starting the game. So that's in our start section. So in the beginning, we're effectively just going to set our players, right? And then we're going to create the board. We're going to drop a penguin in the board. All right, actually, let me just jump back a second and just show you how that board's represented. All right, now I probably could have used a data workflow to automatically generate this and make it a lot more dynamic, where I could say, hey, if I want a 7x7 board, I could, in theory, easily create 7 rows using a create table. I could have done create table with 7 indexes and then done create fields to actually do all of this. For whatever reason, I wanted to map it out. But I think it helps really for illustrative purposes here that this is how the board is structured. You have an X and a Y column. I'm combining them together to make the matching of things a little bit easier. And then I have the status of each one of those blocks. All right. Now, when the game starts, we need to randomly place that penguin on the board. Okay. So what happens there is basically you're taking a random value between 1 and 6, and then another random value between 1 and 6. So a random X and Y, concatenating that together, and then filtering the board to find that specific cell, right? Find me the cell where, X is A, which is this thing coming in, and and arg is Y, which is this. So now I've filtered it down to one specific cell. I'm going to set the status of that cell to be the penguin, which is the Qork. And then I'm just going to add it right back onto my board. And now I've got my penguin randomly placed. So that's the initialization of the board. Once that happens, we're ready to start playing. Okay. So within the ready to start play section of it, we're going to trigger a bunch of data workflows to happen. Okay. And we're going to walk through some of what these data workflows do. But generally speaking, what you're going to see throughout these data workflows is, I know we've talked about that component a lot. Besides being a snowflake builder, as I showed during the Snowology presentation, it's presented a lot as an ETL tool. You want to take some data from some API endpoint or some submission data you've saved. You're going to run it through a data workflow to manipulate fields, filter data, so on and so forth. And then you're going to output that and then likely throw it into a grid somewhere, or maybe call out to some other API. So that's a very common use case of the data workflow. But we wanted to think about it here almost as a function, right? And really do a little bit of an exercise into functional programming within Unqork. So each data workflow, while it does a little bit of ETL stuff, is also going to be treated a little bit like its own function. And again, in that functional programming paradigm. So, as I dig into them, we'll see how that all goes. Okay. So what are some of the things, what do these data workflows do, right? So it does a data workflow current player. So down here, this is a data workflow. Again, it's a function where it takes in the current user, it takes in the current player, and effectively just says, hey, is the current user the current player? And then it just outputs a Boolean. Now, what it's doing here is output a Boolean to underscore self. Now, as I said, this is a year-old application. And actually, in the last year, I do not believe you were able to output a data workflow to itself by using this pattern of underscore self. Now, the reason for that, if I understand, was because some people, you might be possible to get yourself in kind of a looping nature if you have something consistently trigger itself and not be able to break out of it. So there's some concerns about why you might want to do that, but there are other reasons why you would output a data workflow to itself if you did want to create a loop and you had a condition or build any kind of recursive function with a data workflow. Or even just to set the value and then use that. Again, thinking about functional programming, a function could be used as an argument to another function. Functions could be chained and things like that. So, almost think about it as maybe chaining in an object-oriented programming, or functions as parameters in a functional programming approach. So in this case, I am actually outputting a value into all my data workflows. Again, I don't know if underscore self still works. I know you can, and I probably, shouldn't be telling you all this. Even though data workflow current player is on the drop-down list, you can type it in. So if you really love the ability to output data workflows to itself, go right ahead. You won't hear me complain about it. Cool. All right. So that's how we basically just check if someone's the current player. To check if someone's a watcher, it basically says, hey, is the game in progress? If it is in progress and the current user is not currently playing the game, then they're watching the game. And again, they're just going to see that hammer flip back and forth as you saw mine and Danya's screen, or saw my screen and the hammer flip back and forth between Danya and myself. That's what a watcher would see. Okay. And then what else we got going on here? Showing the join is basically just to say, hey, whether or not, to show that join button, which you didn't see because Danya joined on her end, but there would be a button that says, hey, join if the game is currently in progress. And then there's this idea of drawing the board. Okay. So drawing the board is actually every time someone makes a turn, drawing that board and marking the things hit that were hit and so on and so forth, and figuring out if things are active or not. Now, before I show you how to draw the board, let's just look at the board itself. So this is the board itself, all using a combination of buttons and HTML components in Unqork. All right, and you'll see that, this one says player 1, it says watching player 2. You see both of the icons, this icon meaning it's my turn, this icon meaning that I've won the game. The game status, of course, is going to say the game status, not the word game status. And the way that that's all happening, at least from like replacing some of these nice text, which also renders nicely in Designer. It's always great when you can have your front end and your back end look pretty close together. So this, achieves that, versus using a content component, because as I joked in the presentation, no content components, please. And in fact, there isn't a single content component in this, if anyone was wondering. And down here, it uses content outputs, right? So I'm actually able to output the content of an HTML component using this. So if the status is waiting, then I want to make the game status as content, updating that element to say waiting for opponent. And you can see the same thing happening, dynamically putting in player names into the HTML section that has the player's name. Okay, so that's going to happen every time the turn, because it's watching right now. This is a watching decision, and it's watching the status in the turn. So it says if there is ever a change to the status or a change to the turn to execute this decision. Now, there's a number of other inputs in this decision that are all marked as silent, which basically says, hey, I want to use these inputs in my decision, right? I want to output the value of the player one's name or the current player's, whether or not to show that hammer. I want to do that, but I don't want any changes to these properties to trigger this decision to run again. So I want it as an input, but I only really want these two to actually, indicate or dictate whether or not this decision is going to do what it needs to do. Okay. Cool. And then inside are buttons, right? So for each button that represents one of those blocks, we've effectively just have it triggering an event, right? So there's a few different types of buttons that you can use in Unqork. Everything from a save button, which when you click it, it's going to save the data that's on your page. You can use it to validate all the data on your page. You can also use it to trigger events, which is basically broadcasting to every component that may care in your module that this event was just triggered, and then a number. So think of it almost as like a pub sub system within a given module, where this button is going to publish an event that says hit underscore 1x1, which means that the button or the block in the position of 1-1 got clicked. It's going to broadcast that event, and then anyone can subscribe to that event and do what they want with it. Right? So now, because again, think about it this way: if we wanted, we don't want to do a trigger on click here and trigger 36 different components based on, okay, well, this one trigger, decision 1-1, decision 1-2, decision 1-3. We want it to happen once, and we do that through events. Okay, so now that we've kind of shown how the board is constructed, an event that gets triggered when you click it, how all of that game information is going to dynamically update, let's talk about drawing the board. Okay, so that's going to be down in this board section. And again, this is actually going to run through each and every time a change is made. It's going to run through and it's going to redraw the board with the latest statements or the latest state. All right, so it's going to take in the board and it's going to do some things to say, hey, is the game in progress? If it is, then check to see if the current player, needs to do some validation to make sure that the board is only active for the person whose turn it is, and everything like that. So if the game is in progress, but the current player is not, the current user is not the current player, because again, this was that data workflow current player, right? Where I was using that as a function to say, this function is going to return true or false of whether or not the current user is the current player, which that means then I can use that component as an input to say effectively true or false. So that's where I'm plugging it in to say, so I don't need to recalculate that logic again, effectively using this function as the input to another function, which is this function called draw board, to actually go ahead and draw the board. And it'll, again, disable it. It'll enable it or disable it depending on the user. Then we have to go in and we actually need to mark whatever block was hit. We need to mark it as being hit. So we change the UI of it. I think you saw it changes the color, right? So it turns it into a dark blue. You see I can't click it, right? So it disables it. It makes it dark blue. This one is obviously always being redrawn as having a Qork inside of it. So in order to do that, we're leveraging this special output of the data workflow called the group output, okay? Which allows me to do multiple outputs from a data workflow, any one of the outputs that are available in Unqork's component. So remember the initializer back over here? Let's jump over here. I can set values, triggers, steps, duration, invisible. I can do that, all in one shot in a data workflow for multiple components. So effectively what we're doing here is we're taking the board and we're going in and we're going to, let's make this a little wider. We're going to basically concatenate again from the button, figure out what the button click was, right? So this is basically concatenating the property ID of each button. Okay, because that's what we want to do here. We want to change the UI of the button because each one of these squares is actually a button component, just styled to not look like a button anymore, right? So when it's been hit, I want to mark it as disabled and I want to turn it into this dark aqua color, right? So I'm going to go in and I'm going to actually add a custom class. This is saying for each component, so this is the create field. Again, it's going to iterate through every button in this board. It's going to say for each button, I'm going to set the custom class attribute to the status of that block inside of our board object that we showed before inside of our schema. All right. That's in one shot going to output every single button status by doing group. Okay. So you can have very, very, very complete, very dynamic and unlimited outputs all through a single operator. I don't need to have 36 outputs where I'm going to set 36 different statuses. We can do it all in one shot with group output. Okay. Great. So that's how we draw the board. So now the board's drawn, and then the same thing here for board enable and disable. Again, it's just another function taking in whether or not it's the current player, and then effectively just doing the same kind of group output to say, no, it's not disabled if this is the enable function. So as long as, a gate, I don't know if we talk about a gate, this is basically just a logical gate. It says, hey, if a condition does not mark as true, do not proceed. So once again, using that other function of a data workflow current player to say, is the current player, is it their turn? If it is not their turn, nothing after this gate will process. And if it is, everything will go. So assuming it's my turn, I'm allowed the board to enable. So no matter where you may call board enable from, it's always going to check to say if you're the current player and not allow you to override that default, those kind of rules that you would want about enabling. All right. Oh, now I don't know if anyone can hear. Now the whales are having a dance party. They must have found their mate, and now they're celebrating with one another. Right on. Cool. Dr. Snow going a bit strong. I hope that's a good thing. I hope strong is good here. Right on. All right. So continuing along, let's go now to actually looking at those buttons. We talked about that rule. See what happens when that button gets clicked. Okay. So this is our decision, which is going to be watching and listening, I should say, and really in this case, for any of those button clicks. But we only care, maybe we have multiple buttons that are subscribing or publishing different types of events. We only care about the button events that begin with hit underscore, because every one of those events I put was hit underscore, right? So this is a good way. Using a decision to watch for or to subscribe to these events allows you to limit your scope of the events that you care about and then continue with logic. So basically, if there is a button click that begins with hit, I'm going to output the value of that button click into another field, right? Which is then going to start to trigger the real fun stuff, which is the turn itself. Okay, so that's that event hit button. So this is our turns. Now, all the functions that we're going to kind of go through now is what happens after I've hit click and how is all of that built, in this codeless manner. So the event hit gets output, and that's going to go, and this initializer is going to look for that event hit, and now it's going to start to trigger all of the processes. Right. So the first thing it does, it disables the board. It's kind of like once I've clicked it, I don't want to be able to click again. So let's just turn the board off. And then, of course, it's not my turn anymore once I've clicked something. So I should be able to click something again anyway. So first thing we do is disable the board. Okay. Now we're going to go through. And again, we're going to go into another one of our functional data workflows here, which is going to extract out which cell was hit. Because all of those events started with hit underscore number, X, and number. So a very nice convention that allows us to use string splitting to parse it out. So if folks aren't aware of what like a split string is, most programming languages have a string split function. It's often called split. And in an Unqork, you can still split things through the data workflow in a visual manner, which says, hey, I want to take a given string and I want to break it into multiple pieces. And those pieces will live in an array. I want to break it into multiple pieces and based on a given delimiter. So in this case, I want to break the event apart on that underscore. So I'm going to take hit, and then I'm going to take the 1x1, right? But then all I care about there is the 1x1. So I'm going to reference the first index, or the number one index, because array indexes start with 0. So the hit will be in the 0th array index of the array, and the 1x1 will be in the first index of the array. So now that I've grabbed that, I just want to string split again. In this case, I'm going to split on x. So based on those two splits of the string, because we followed that convention, we now know the exact x and y coordinates that were being hit. So now I'm going to grab the 0, which is going to be my x, and then I'm going to grab the 1, which is going to be my y. Okay, and you'll see I'm going to output it into a hit, and I'm also going to output it into a temp variable. All right, because what we're going to show is that you need to kind of do a lot of almost recursive, repetitive, logic to see, like I showed with that unsupported block. I might click one block, but that doesn't mean that that's the only block that's going to fall down. I need to run through, and I need to do a lot of validation to see if other blocks were going to fall. So I'm going to have to rerun a lot of logic over and over and over again based on temporary variables. So that's why we're doing that temporariness. Okay. So after the hit, to see which got hit, we're actually going to process it as being hit. So this says, give me any x, y, so which we're going to store in that temp variable. We're going to concatenate it together to make it, very easy to match in our filter, right? Which is basically, remember how I had an x column, a y column, and then I had that column that was xy, which was like 1, 1 next to each other. I did that to really just simplify filtering throughout all of these tasks, where I'm going to have to take the entire board, filter it down to a single block, and understand more about the context of that block. So that's what I'm doing here. Now I'm filtering it down. So now I have one block out of this board, which is the one that's at this x and y. Okay. I'm going to get the status of the board, and I'm going to say, if it's the penguin, for whatever reason, the penguin got hit, then I'm going to create a value called over, and that's the end of the game. Okay. So now, of course, you're not going to hit the block itself, but you may hit another block, which results in this block being hit. So this function here, this data workflow function, is going to be run against that block at a certain point if, in fact, your hit triggered eventually that penguin to get hit. So we're going to reuse it here. And of course, then we're going to say, hey, it was the penguin. The game is over. Sorry, you lost. But otherwise, we're just going to mark the status as hit. And again, we're going to add it back onto our board, because our board, the actual array of the board, and if I were to show, and I'm going to dig in our next episode, a little teaser, because I know we're already at 47 minutes. We're going to get into the next episode playing against the AI, how the AI can, calculates what move it should make. And what we're going to show into some of the debugging things that you can do in Unqork, and how you can kind of debug, potentially limitless scenarios of what blocks you can hit, and really do the right amount of testing to ensure your application is working. You'll notice the board is not going to it doesn't have to be stored in a sequential order. I mean, in that data table I showed you, it was 1, 1, 1, 2, 1, 3, 1, 4, so on and so forth. But ultimately, it's going to end up in a completely randomized order. And then we're just going to output things accordingly. So we're constantly just going to be filtering, making a change, and appending it back in. So again, the order is going to change, but that's inconsequential to the drawing of the board. So this is just a function with a singular purpose of marking a given XY as hit. And then, of course, ending the game if that XY is the penguin. Okay. Now we start to get into some of the more complex stuff. Well, maybe not this one. So basically, this is saying for the two that were originally hit, okay, not for the two temporary, what we want to find is we want to find the blocks around it, okay? Because the moment I've hit a block, I jump back over. If I hit this block here, what I need to do is I need to go to every block that's around it that it touches and that it might be responsible for holding up and supporting. I need to go check did this block going down result in more blocks going down? Okay, so like if I click this, I'm going to have to go check, hey, did this one go down? And then, of course, again, that's going to be recursive, because then if I calculate that this one has fallen, well, then I need to go calculate did all the ones adjacent to it fall as well, and so on and so on and so on. So effectively what this is doing is it's just figuring out what are the adjacent blocks. Okay, so that's a nice little formula here where it's effectively just saying, a minus 1 and y, a plus 1 and y, a and, or, x and y plus 1, x and y minus 1, y and y plus, or x plus 1 and y 1. So that's the coordinates of the 4 around it. So now I basically said, okay, I'm going to result in only the adjacent blocks. I only care about the ones that are not hit. So you'll see I'm pulling this out of the lower end of the filter here, just to make the filter look nicer. I mean, you can also do this. What folks might be familiar with to say not equals to. I personally think it's just easier to look at with an equal sign and then take it out of the non-matching set, which is at the bottom output of a filter. And then now this is what I'm going to start to process, is all of the unhit blocks that are around there that may have fallen as a result of my move. Okay, now we get into loops, right? So this is where we're actually going to go in and we're going to loop over everything, and we're going to check to say whether or not it's done. So, the first thing we want to do is check if the game is over, because let's say I hit a block and it caused the penguin to fall, then the next time this loop is going to execute, the game is actually over. There's no need for me to continue to process the rest of the board, because the game's over. Let's just let people out of their misery as quickly as possible, right? So if the game is over, then we're just effectively going to end the game here. Otherwise, we're going to continue to just loop over all of the adjacent blocks. We're going to output those temp values, remember, because there was the original hit, because we always want to know where we started, but we also want to know in what scope are we running all of this logic on. So we're just going to output those values to the hit. And then we're going to run the function again that's going to say whether or not the block has fallen as a result of other blocks around it to fall. Because when you hit, it's easy. It's down because you hit it. But when it falls, things get a little more complicated. Okay. So effectively, what's happening here is, again, where in order to know if a block falls, we have to look at what's around that block. Right? We have to say, hey, is this block now no longer supported on opposite sides? So in the previous step, we were saying for the block that was hit, what are the adjacent blocks to it? In this step, we're saying for that adjacent block, what is adjacent to it? And are two of those things down? So this is basically what happens inside of this adjacent falls group, is it's just going to check all of those 4, and it's going to say if 2 opposites have fallen, then I'm in trouble and that block has fallen. Okay, so that goes through, and then what I'm doing is if the block falls, right? If as a result of the fact that, now that I've hit maybe, let me just show it. Now that I've hit, so an example would be this one, right? This and this are adjacent. So I hit this. So now I've gone over and I've checked, now I'm checking this to see if this falls as a result of this hit. These two are now down, which means that this falls down. So this process is saying, hey, is this down? And is this down? The answer is yes, which means this goes down. And because that goes down, now I need to add this block to the list of blocks to check, because this has fallen. I need to make sure if this has fallen. Now, in that case, this has not fallen because this has support fully across this row. So this block is going to stay up, and that'll eventually be how that loop or that data workflow fall function responds. But that's what I'm doing here over on this part, is I'm adding those appended statuses. Okay, I'm adding that into my list of things to check. So I'm taking in that original list of adjacent blocks, and I'm effectively appending to it the list of adjacent blocks to the one that I'm checking, but only if it's fallen, right? So this is a create value. It comes if the block has fallen. If the block falls, then I want to append the new adjacent blocks into my array, which means that as I continue to process that fall loop, it can potentially grow longer and longer and longer. So the loop will continue to, increase the amount of iterations it takes as I add more content into it or more blocks into it. Now, again, if the block falls, I just call my data workflow hit function, right? I don't need to recreate that logic. Again, using those data workflows as functions trigger that function again. It's going to have the temp X and temp Y as the input. It's going to mark it as hit. And also, of course, it's the penguin. It'll then trigger that. So again, see, that functional programming aspect to it. All right. So that was the fall. So that's going to go, that's going to go, that's going to go, that's going to go. And then ultimately, when my turn is over, it's going to trigger off some initializers. If the status of the game is now over as a result of my turn, then I want to initialize the process to end the game. Otherwise, I want to initialize the process to end my turn. Okay, so inside of, let's just say I didn't end the game, I just wanted to end my turn. What happens there? I basically just kind of reset some of that fall logic. I swap the turn and then I end the turn. So data workflow change turn is a function that is just going to swap whose turn it is. And then the plug end turn is actually going to go write the data that's going to tell the server, which is functioning as the middle person between both players, that the next person gets to go. And that's, I think, where I'm going to ultimately end is that refresh. So I think we're going to be pretty good on timing here. So what happens in plug and turn? And this is, I think, going to talk about some other features that you might, that are probably not used as much as they should be in Unqork, and I want to give them some love today. And it's really all about writing submission data. Okay. So in this case, I'm just going to update the submission that's active in the browser through this plugin. So this is my submission ID. I have access to it throughout my entire module, and that's what I'm going to update when I make a turn. Okay, so what am I doing inside of this? So I really only need to do a couple things. I need to change the current player as part of that update, which once it writes to the server then in the database, that's how the other person is going to know, oh, it's my turn. And then they're going to be presented with their turn. Okay, we're obviously going to update the board. So we're going to tell you what the board now looks like. And then here's two other things. Now for up here, if you're familiar with writing data to submissions in Unqork, you're used to putting data dot in front of a property. But down here, we have increment data and we have data filter, two different types of mappings and inputs that you can do into a submission write. So what are the two of these things doing? So the first one, increment data. So I want to increment the turn attribute is what I'm saying. I want to increment it by 1. Okay, so what I could do here is I could have a calculator that said, well, I want to increment the turn by turn plus 1, and then I could just write in data.turn is turn, which is what the next thing is. But I don't need to do that, right? This increment data is going to do it for me. It's going to tell me it's going to tell Unqork, or even at the database layer, to increment this property by a certain amount. Why is this important? This is really important to deal with, to really prevent yourself from getting into race conditions, to really help sequencing of writes, versioning of writes, and things of that nature, where this increment data is going to be an atomic operation. Okay, so let's think about a world where maybe we want to build a game where multiple people are actually able to take turns at the same time. And there's nothing stopping us from taking those turns. But each time somebody takes a turn, we want to increment some counter that says this turn has been taken. Right? So if everyone's kind of playing all at once, but we still need something that's incrementing how many actual turns have been taken. If we tried to do that in configuration, you're not going to probably get the right result. Because what's going to happen is, let's say me and Danya both took a turn at the same time, and the logic to increment that data was not kind of at that database level. Most likely, I'm going to increment it by 1, because I'm going to say current turn plus 1 is, so let's say it was turn 2, and I took a turn, which should make it 3. I'm going to write 3 into the database. But then on Danya's end, from her perspective, it might still look like turn 2. Because there is all that network latency where my request needs to make it to the server needs to update, and then that update needs to get out to her application, right? So that latency alone, regardless of what application you build, whether it's, in a coding language or in a no coding language or a low coding language, you're always got to deal with the network, and folks can be distributed anywhere around the world playing these games together. Incrementing this data is going to ensure that it always increments by 1. So even if Danya and I took our turn the exact same time, it's going to go up 2 turns. So consider this if you're ever trying to build something where you need like that really, atomic level updating and really and ensure that that's is always going to happen for The second feature of this right that I want to call out is this data filter. Okay, where again, so what this is doing is it's saying to Unqork, only write the data if this condition is true. Now, again, of course, you can configure that condition in your module, right? I can say, oh, I only want to submit this plugin if the current player is me. But maybe maybe in that world where multiple folks are acting at the same time or something, what actually happens in the database might be different from what you're currently seeing in your browser. And you want to make sure that you don't override, some other really system level control. So this is going to ensure that no one can sneak in and put their turn in when it's not their turn, because that's always going to be validated at the last mile on the current state of the data when the data is going to be written. So this is always going to increment our turn by 1, and this is not going to allow a write to happen without it. So let's say I make a turn and then I try to get really sneaky and go like hack my browser and try to take a turn again. It's not going to let me take that turn. Not possible. Okay, cool. So consider those. It's really key if you're doing if you need to build any kind of locking mechanisms, if you want to do like whether it's pessimistic or optimistic locking, you might want to consider in your submissions. You've had multiple people interacting on at the same time. Consider some of those database level, abstractions that Unqork provides through its APIs, rather than necessarily building a lot of that configuration on yourself. It's gonna be ensure that you're always getting the right data. Okay, and then really quick, because I know we're right at the hour, there's this concept of refreshing. So when it's not my turn, I'm refreshing the page or refreshing the state of the data to see if it's my turn. Okay, so Unqork does not have WebSockets, and WebSockets is probably a way that a lot of these online games would happen. That's not a feature that's available, but it can still be achieved effectively through a polling mechanism, where what you're going to do is every 1, 2, 3, 5, 10, however many seconds you want to wait, it's going to just check that submission again. So all it needs to do is a very simple get submission. Just pull back the current state of the data and output that data, right? And then if anything changes, so let's say I output this data and the status and the turn have changed because Danya took her turn. So then when I get this data back, the status is probably going to be the same, but the turn has updated, which will then trigger that decision we showed earlier to repaint the board and repaint the current player and the numbers of turns and everything like that. So this plugin is just going to basically be running in the background the whole time to see if anything's happened. All right, so you can effectively, again, just do that. And the way that you kind of create these polling mechanisms where you can pull back and dynamically update your screen, kind of like you used to do with Ajax back in the day, right? If folks remember when Ajax, not the cleaning product, right? That was always the joke, but the JavaScript technology took over what you can do with the web. And it's done through a timer component, all right? So the timer component here is saying after a certain amount of time, trigger this plugin, okay? I default that timer to 86,400 seconds. For the programmers out there, I'm sure that number looks familiar to you, but I know it's not going to happen anytime soon. And then when it's going to trigger. But then I want to make that duration shorter and shorter. So the way I have it configured right now is to run every 3 seconds, okay? Now, a timer component will only restart itself in Unqork, similar to how a component on watch will only refire if the data itself changes, right? So if I kept outputting the duration to 3 seconds, it's not going to restart because from the timer's perspective, it hasn't changed. It still says 3. Again, it's just like a watch in Unqork. The data needs to change. So this is one solution that you can do to ensure that every time it runs, you get a unique time. So this is effectively using Moment, which is the interfaces into a lot of date-related capabilities to format a current timestamp as 3.x. Now this x is the number of milliseconds that have passed since the Unix epoch of 1970. Right, so you'll see that timestamp number in a lot of programming. So what happens is every time this run, it sets it to 3.x 1119999, whatever, a bunch of digits, which means that every iteration is technically different because a millisecond has passed since the next time that this runs, but it's unique and it doesn't really add. It only adds a negligible amount of additional time that it needs to wait, dot and then the 14th decimal place or something. I know folks will just use rand as well. You can use 3 dot and a random number between like 1 and a million to ensure you're going to get something random. You don't want to do random between 1 and 2 because obviously the odds of getting the same number twice are high. So there's a few different ways. Just make sure that your timers are unique durations and you can kind of figure out the best way to go. And if for whatever reason, to this day, 20 years of software development, I still do not trust random numbers. I still think they're going to give me back the same random number. So that's how it's going to refresh and refresh and refresh and refresh and refresh. So cool. That gets me through everything I wanted to get through today. Next week, as I said, you can play against the computer, which I actually did have up in a second. I don't know why I'm going to start a brand new game. You can play against the computer. So we're actually going to talk about how this works, how the AI goes about determining what the move that it wants to make is for you. And then, as I said, we're going to talk through some debugging solutions and how you can use a number of capabilities, some that existed a year ago when this was built, some that are brand new as of today that I wish I had for me back a year ago. But obviously, the platform is always getting better and better every single day. So a lot of cool stuff that's coming that I'd love to be using, and I'm going to be happy to show you next week. So that's it, folks. Thank you for tuning in. Thank you for listening through Don't Cork the Ice. I'm sweating in here, so I'm definitely not in Antarctica. But this was great. Really appreciate it. Appreciate all of the action in the comments. Make sure you like and subscribe and all the things you're supposed to do if you haven't already. Appreciate your time today, and we'll see you next week where we continue our journey through Don't Cork the Ice and AI and all that good jazz. So until then, happy uncoding, everybody. Take care.